Okay? So when we look at that, what is your first thought that comes to your mind?
Alternating, maybe?
Good. What was it that makes it alternate?
The sign.
The sign. Good. So what is the first step in an alternating series test?
Do you want to take the alternating part out?
Okay, so let's drop it. Let's just look for the a sub n. And a sub n would equal what?
E to the n? 1 over e to the n?
Good. And what do I do with that?
You find if that's divergent or convergent by finding the limit, if it's equal to 0.
All right, so okay, what does that equal?
0?
Good, because it's a number over infinity, which definitely equals 0. What if I didn't get 0? What would I write here? If it doesn't equal 0, then you're right, diverges by nth term test. Do you understand?
The nth term test?
Isn't that what the nth term test was? Let's say we didn't even see the alternating part, and we take the limit of this series, and we don't get 0. The nth term test says that it diverges, or the divergence test, whatever you want to call it.
Oh, okay, yeah.
Okay?
Yeah.
So the first condition of AST is the opposite of the divergence test. So if we pass it, we move on to AST. But if we fail it, then we say diverges by nth term, or you could have put divergence test.
Okay.
Then at that point, what you do is what? You tell me.
You have to see if it's decreasing.
Okay, how do I see if it's decreasing?
You can do the derivative.
Okay, let's do it both ways. First way is the derivative. So if I look at that, what is the derivative of that?
Negative e negative 1 over e to the n. Yeah.
Good, because whatever I plug in for the denominator for n, I'm just going to multiply times this negative sign, so less than 0 for all n. Okay. The other way we could have done it is done a proof. Which one of these is bigger?
The one on the right.
Okay, and then when I flip both sides, what happens?
The sign switches. The one on the right is smaller now.
Okay, so then, therefore, it's decreasing. Do you understand that one? Okay, so now that we've proven that it's decreasing, we've passed both checkpoints of AST. It equals 0 when you take the limit, it's decreasing. Now what?
So it's convergent.
No, because of conditional convergence and alternating series, there are some series that pass the conditions of AST, but they fail other conditions. So it's called conditionally convergent. The way we got to prove that whether or not it's conditionally convergent is we got to look at just this series. I'm sorry, this is supposed to be a 0. Okay, what kind of series is that?
Would it be a... What do you mean, what kind of series? Like, what type of proof we could do to it, or...
Yeah, we just
Did you?
This is a brand new problem now. What we're doing is we're looking at this as a whole different problem.
It can be a geoid, right?
A what?
Geometric?
Yes, ma'am. Okay. Stop doing that. So we're going to make this into a GST. So how do we make that into a GST? What's the first step?
You take n to the outside.
Okay, so what we can use is the fact that 1 to any power is still 1, so we can raise it to the nth power. And then I think this is what you were telling me to do, is just rewrite it in the form of the geometric series. Now what do I do?
1 over e is less than 1, isn't it? Okay.
1 over e is approximately equal to 0.37. And
No. Okay.
absolute value of less than 1 is actually convergent.
Yeah.
Okay? The easiest way to remember those is this. All of them that are compared to 1, okay? That's p-series, geometric series, ratio, and root test. All those are compared to 1, less than 1 or greater than 1. They all converge except for p-series. P-series is the only one that diverges when it's less than 1.
Okay.
Got that?
Mhm.
Okay. So converges by GST. So what's the big picture?
So it would be convergent because it's both of the sides came out convergent, right?
So because they're both convergent, then you would write, therefore, is absolutely convergent. You understand?
Yeah. So like you have to do 2 tests on it.
Yes. First, you do the alternating series, then you drop the alternating part, and then you say, okay, let's just look at the problem without the alternating part. If that alternating part diverges, then you write down conditionally convergent, okay? But in our case, what happens? It converged by the GST, so we wrote down absolutely, under all conditions, it converges.
Okay. So you always do the alternating series first. Okay.
Got it?
Yeah.